All right, guys, welcome back. We are going to finish up lesson 6.6. So 6.6, day 2. In today's lesson, we're going to look at, again, solving exponential and logarithmic equations. We're going to look at some harder log equations, solving exponential inequalities, and word problems. So it looks like we have a total of 5 problems that I'm going to work you guys through, and then you have some extra practice problems to work on as well that I will maybe provide the answers to, but you guys work on those independently, okay? All right, so okay, so let me give you the notes for the first set of problems. So we're going to solve log base 6 of 6x plus log base 6 of x minus 1 equals 2. This is different than the problems we saw in day 1 because in day 1, we either had logs on both sides or we had a single log. Here we have 2 logs on the same side, and if I move one log to the other side, I'm going to have a log and that 2 as well. So there's really no way to isolate the logs on both sides. So let's talk about what we can do here. Okay. So my notes for you are when multiple logs, you want to simplify each side and that's an and symbol and combine logs, use log properties. So we're going to be condensing, right? Remember addition pairs with multiplication, subtraction pairs with division. Remember those rules? That's what we're going to be doing here. All right. Then you're going to either drop logs or change forms. Then you're going to solve for x and check. Remember, you can't log a negative. Okay. So, okay. So for this first one, let's go ahead and simplify. Let's try to condense the right-hand side. Since I have addition pairs with multiplication. So I'm going to write this as log base 6 of 6x times x minus 1 equals 2. All right. I do have to distribute the 6x to both terms. So it's log base 6 of 6x squared minus 6x equals 2. All right. Now you can either drop logs if there are logs on both sides of the equation or change form. So I'm going to change forms here. I'm going to go from log form to exponential form. So remember, in log form, it's bacon and eggs, and I need to go to exponential form, which is base, which is 6, raise the exponent, which is 2, equals the answer, which is 6x squared minus 6x. All right, 6 squared, 36, equals 6x squared minus 6x. Since this is quadratic, I'm going to set it equal to 0, and then I'm going to factor and solve. I'm going to have to erase my directions. All right, so setting equal to 0, subtract the 36 from both sides. I have 0 equals 6x squared minus 6x minus 36. To factor, look for the GCF, which is a 6, so factor that out. X squared minus x minus 6. What two numbers multiply to give you a negative 6, but add to give you a negative 1? You're going to have a negative 3 and a positive 2. Set each factor equal to 0 and solve for x. So you have x is equal to 3 and x is equal to negative 2. All right. You want to check to make sure that when you plug it in, it doesn't leave a negative that you're logging. So if I plug 3 in, 6 times 3, that's 18, that's good. And 3 minus 1, that's 2, that's good. Okay, if I plug in a negative 2, 6 times negative 2, that's negative 12. You can't log a negative, okay? And negative 2 minus 1, that's going to give you a negative 3. You can't log a negative. So this is a false solution. It's not going to work because it would leave a negative to log. x is equal to 3. Okay. If I couldn't factor, all right, luckily I was able to factor, but if I couldn't factor, I'd have to use quadratic formula. So keep that in mind. Um, and if instead of log, if it was ln, you can still change forms. Just remember that your base is e instead of base 10, or, the base is e if it's an ln. Okay. All right. So that was problem number 1. For problem 2, now this is an important note for inequalities. Okay. You can't change forms across inequalities. Okay, so if you have an inequality, changing forms is not going to be an option. All right, instead, you're going to log both sides in a helpful, and I'll explain what I mean by this, helpful base to free the variable. All right. So yes, it's an exponential form. And I know a lot of you are going to be like, I just change forms into log form. You can't do that. Okay. But what you can do is you can log both sides, and whatever base you want to use, you can use. So I'm going to say, let's take log base 2 of both sides. And let's see if you understand why I chose base 2. I could choose, again, any base I want, but I chose base 2 because I'm going to choose a helpful base. And as long as I use the same base on both sides of the inequality, it's fine. It's a legal math move. Now, the reason I chose base 2 is, do you guys remember the rule? When you have the base matches the base, then that means it simplifies to what is in the exponent. So on the left-hand side, because the base matches the base, this simplifies to just x is less than log base 2 of 36. Well, guess what? At this point, you are done. You just have to use your calculator. Okay. The goal is to isolate x to solve for x. I have x by itself. So I'm just saying take my calculator and evaluate log base 2 of 36. So math, go down to log base 2 of 36. All right. And I get 5 point, I'm going to say 17. Okay. So I have x is less than 5.17. All right. Okay. Let's see. Isolate the base. Remember, you can't log them. Okay. So that is it for that one. Let's move on to number 3. I'm just reading my notes, making sure there's nothing else I need to say about that one. Number 3. All right. So in this one, it's an inequality as well. We cannot change forms across an inequality. So instead, just like I said, you can use whatever helpful base you want. For these problems, you're going to assign the base of log as the base of both sides to free x. Okay. So what I mean by that is, since I have log base 10 of x is less than or equal to 4, whatever the base of the log is, you're going to use that as the base of both sides. So you're going to write 10, that's the base, and then log base 10 of x is less than or equal to 10 raised to the fourth. So basically, what you're given becomes the exponent, and you're using 10 as the base of both sides. And I chose 10 because that's the base of the log that was given. If this had been a 2, I would write 2 log base 2 of x less than or equal to 2 to the fourth. If this was a 13, I would have written 13 raised to the log base 13 of x is less than or equal to 13. So whatever the base is, that's what you're going to assign to both sides. And the reason is, if you remember the trick, when the base is the same as the base of the log, whatever you're logging is what it simplifies down to. So the left-hand side simplifies down to x is less than or equal to 10 to the fourth. And now I can evaluate 10 to the fourth. X is less than or equal to 10,000. Now, for this problem, we do need to restrict our answer, okay? And the reason is this is a log problem. What do I keep telling you? You can't log a negative, okay? So since we can not log a negative, make sure to restrict answers if needed. Okay. All right. So x is less than or equal to 10,000. However, x has to be greater than 0. Okay. Because you can't have a negative as your x value. Now, this is the answer for this one. I did not have to do this for the problem above because the problem above was exponential, right? It wasn't a log problem. But if it's a log problem, then you're going to need to restrict your answers because you can't log a negative. All right. Okay, let's see what else we have. Okay. Here it says you buy a laptop for $2,000. It depreciates at 18% per year. When is it worth $1,000? Okay. So this is exponential decay. It's depreciating, so it's exponential decay. So I'm going to use y equals a times the quantity 1 minus r raised to the t. All right. A is your initial amount, right? So y equals the laptop originally cost $2,000. Your R value, 18%, but change that to 0.18, 0.18 raised to the t. All right, and I can simplify 1 minus 0.18, so it's y equals 2,000, and then I'm going to have 0.82 raised to the t. Now, that's my function. Now, for this problem, it says, when is it worth 1,000? So when is your t time, right? When is it worth 1,000? So you're going to plug in 1,000 for the y. 1,000 equals 2,000 times 0.82 raised to the t. Now, if you remember at the beginning of this chapter, we did problems like this, but this is where I'd say, all right, guys, we don't know how to solve for t yet. We're going to take our calculators, we're going to graph the function, and we're going to look to see, we're going to trace and look to see when y is 1,000, what is the x value? You guys remember that from earlier in the chapter? But now we do know how to solve these problems, okay? Because we know how to get t out of the exponent. We can change forms. But first, let's isolate. So let's first divide both sides by 2,000. So I'm left with 1/2 equals 0.82 raised to the t. Now at this point, you can change forms, which is what I would do, or you can log both sides, okay? But I'm just going to stick with changing forms since we do that a lot throughout this chapter. So I'm going to go from expo to log form. All right, so in expo form, we're base raised to an exponent equals the answer. So B, this is E, and that's A. And I want log bacon and eggs. Log base 0.82 of 1/2 equals t. Okay, so now I'm going to pick up my calculator and I'm going to type that into my calculator to solve for t. All right, so it's going to be math, go to log base. My base is 0.82 and 1/2 or 0.5. Oh, that's not a 5. That's a 2. Push enter and you get approximately 3.49. Okay, so T is approximately 3.49, or maybe you would round to 3.5, 3.5 years. Okay, so in 3.5 years, 3.49 years, your laptop depreciates to $1,000. Okay. All right. And the last word problem, you deposit $5,000 in an account that pays 5% annual interest compounded quarterly. So this is one of those compound interest problems. When is your balance at least 5,500? At least tells me it's going to be an inequality. Okay, let's first start by just writing our compound interest equation down. A equals P, the principal, times 1 plus R divided by N raised to the NT. Okay, your principal amount, how much you deposit into your account to start, is $5,000. Your annual interest rate is 5%. That's 0.05. All right, we're looking at compounded quarterly. That's 4, right? Your N value is 4. So 4T. Okay. And then we can kind of clean it up if we want to simplify inside the parentheses. What does that all simplify down to? It's going, when you do the division and then the addition, you should get 1.0125 raised to the 4T. So this is our function. Now we want to use this function to see when the balance, that's your A value, when your balance is at least 5,500. So at least means that you want your balance 5,500 to be that amount or greater. Okay, so make sure you put the right inequality symbol in. 5,000 and then 1.0125 raised to the 4T. Okay, so again, what's in your account, this amount here has to be greater than or equal to $5,500. Okay. All right, so from there, I'm going to again isolate the part of the problem that has the exponent and then change forms. Or you could log both sides. Or no, you can't. I'm sorry. You can't change forms because it's an inequality. So we're not going to be able to do that method. If it had been an equation, we could change forms, but we can't across an inequality. All right, so let's first divide both sides by 5,000. So that's going to be 1.1 is less than or equal to 1.0125 raised to the 4T. Okay, so remember you can't change forms. All right, so instead, I'm going to log both sides. Okay, so I'm going to take the log 1.1 is less than or equal to log of 1.0125 raised to 4T. Then I'm going to use my exponent rules, my log properties. I'm going to put the exponent in front of the log. So it's log of 1.1 is less than or equal to 4T times log of 1.0125. To get T by itself, I'm going to divide both sides by 4 log 1.0125. That'll leave T by itself on that side of the equation. So 4 times log 1.0125. All right, so it's pretty crazy ugly looking. Let me erase this so when I put my calculator up, I can put my calculator there. Okay. So on my calculator, nope, that's not what I wanted to do. All right, so I'm going to type into my calculator alpha y equals to get a fraction. And the numerator I have, it's log base 10, so I can just use that log button, 1.1, close my parenthesis, and in my denominator I have 4, and then you can do times or it's not even necessary, log of 1.0125, and you get approximately 1.92 we'll round to. Okay, so I have, I ran out of room down there. Oh, let's see if I can squeeze it here. No, I can't. I'm going to put it up here. 1.92 is less than or equal to t, or if I flip it around, t is greater than or equal to 1.92. All right, and that's years. So again, the question is, when is your balance at least $5,500? It would take you 1.92 years, so nearly 2 years for your balance to be at least $5,500. Okay. All right, guys. So for these extra practice problems, what I'm going to do is I'm going to suggest again that you take a minute, you pause the video, you write down these extra practice problems, and you try them on your own. Okay. It'll really, help you guys understand whether or not you're understanding the material or if you're struggling with the material. They're all very similar to the problems I've already worked out. All right, then come back here and I'm going to just list the answers. I'm not going to work every single one out, but if you need help with any of these, feel free to jump on to Google Meet with me during 12th period. All right, so go ahead, pause, try them, and then come back here and check your answers. Okay, so number 1 is x equals 3. Number 2 is x equals 38. Number 3, so I'll make sure I'm listing the right problem. You're going to get 2 answers, x equals 5 and x equals negative 4, but the negative 4 doesn't work. Number 4, you're going to get x equals negative 16 and x equals 4, but the negative 16 doesn't work. For number 5, you're going to get x is less than 0.693. For number 6, you're going to get x is greater than 3.239. The point there. Point. Come on. Point. Number 7. Oh, I ran out of room. I'm going to have to do 7 and 8 up here because I can't, for whatever reason, write down here on the screen. Number 7, when I go down there, this little box keeps popping up, is 0 is less than x, which is less than 10 to the 36th power. And the last one, number 8, x is greater than 12.182. This one we had to put a restriction on because remember, you can't log a negative. Okay, so that's why there's a restriction there. All right, guys, hopefully you did pretty well with these extra practice problems. Like I said, if you need help with any of them, jump onto a Google Meet with me during 12th period, and I'll see you back here for the last lesson of this chapter. Bye.